Hey, we're live. Oh, goodness. Can you turn that down a little bit because I'm going to be loud. And I would rather not hear myself, and I'd rather talk loudly if I have the choice. All right. Welcome, everyone. First time I gave this talk, it took me 90 minutes, okay? So I have 60 in case you're not paying attention to the clock here. My name is Jason Turner. I am a developer, trainer, host of a YouTube channel. I've got 499 episodes up. Monday airs episode 500. Oh my goodness. I have stickers if you want those, so make sure you grab some. I am the author of several books, I guess, at this point. I have my latest book ready to give away as a prize. Say, ooh. Okay, this is my programming puzzles book. This is intended for anyone who likes puzzles. Just so you know, if you've got anyone in your life at all, like, I'm thinking usually like, say, 9-year-old child kind of age range, it introduces Lisp, Python, regular expressions, binary, assembly language, truth tables, and I'm not joking. It actually starts right from the very beginning on this. If you go through it, you should understand those things. I would say, relatively well. That's the goal. This is born out of many years of thinking about how to make computer science information more accessible and thinking about my own nieces and nephews in my life. All right. So I've got projects and things, and I'm a Microsoft MVP for 11 years now. I got my 11-year disc. It's very exciting. All right. I do training. This is how I make a living. So yes, if you find my stuff interesting, I would appreciate it if you have me to your company on site to do training, which I have not yet done corporate training on site in Norway. I have done Sweden, and I'm getting Denmark in a month, so I need more Scandinavian countries. Is there anyone from Finland? No one? Not Scandinavia, my bad. Sorry, from this part of the region. How's that sound? All right. Nordic countries. Was that a better word? Nordic? Okay. I apologize. Didn't mean to offend anyone. Yeah, I have workshops at conferences, but who was in my workshop this week? Who's been in any previous workshop that I've taught? Oh, that was pretty good. Nice. All right. And you come back to listen to me again. So I consider that an honor, honestly. All right, the room's full. Do interrupt me and ask questions, yell things out. I'll repeat them as appropriate for the recording. My training days are like this. I try to aim for very interactive classes. And those of you who have been to my classes, I know you know that. Workshops. I should probably have just removed that slide because here we are. All right, implicit conversions considered harmful. Few notes. I'm going to focus on the implicit conversions that tools don't catch. For the rest of them, you can mostly if you're lucky, rely on compiler warnings. We'll see that isn't always true also. This talk is not nuanced. I had someone complain after the last time I gave the talk that I didn't have enough nuance. I'm not trying to be nuanced. I'm trying to annoy you. What's that?
Change the world.
Change the world. Oh, I was focused on my stuff. I wasn't here, unfortunately, for the last talk. Correctness is ultimately the problem here, but I'm going to use performance to get your attention. Is performance important to you? Raise your hand if performance is important to you. If it's not, you would be programming in not C++, right? I mean, probably. Okay, that just for the sake of the video, that was almost 100% of people. Okay. What's printed? Int. It's not a trick question. Int is in fact printed. Oh, I should have told you how you win this book. You have to surprise me. It's possible someone will say something that surprises me. If no one surprises me, then I'll just give it out to a lucky person who comes up later. I'm not taking it home, I know that. All right, and what is printed? Double? Double? Does everyone agree? Double? Okay. Now what is printed? Okay. Why did the first two compile? Because of implicit conversions, yes. Because of implicit conversions, okay. Or float. No, wait, you all said double. Did you say float? Oh, that was double on the last one. All right, never mind. All right. And why does it work? Implicit conversions, okay. Inherited from C, just for the record. C++ has its own problems. Let's talk about strings for a minute. What is that thing? And this code does compile, just for the record. It's a character array. Wait, a what? Statically allocated. Does everyone agree this is a character array? It's a string literal, okay, but is a string literal a character array or not? C++ it is, I hear. It's funny because, like, you're like, yes, I know this language, but then I question you, and you're like, oh, no. Read-only memory. This is a character string literal, okay. What is the type of str? It is a const character. Okay, who says pointer? Who says it's an array? All right, pointer wins. It is a pointer. So I am going to use the isArray type trait. I'm asking the isArray type trait, is this thing, hello world, is this an array? Who says yes, it's an array? Who says no, it's not an array? Yeah. Okay, no, that's not an array. That's a pointer. All right. So how do I know that this thing is, in fact, actually an array? Do you see this code? Are you familiar with code like this? This is the array reference syntax, which I literally have to look up every time I need it because I can never get that ampersand in the correct place. Is this going to work? Is this going to compile?
If you looked it up correctly.
I'm sorry, if I do what?
If you looked it up correctly.
If I looked it up correctly. You expect this to compile?
Yeah.
Okay. Do we all expect this to compile? At least those of us who are familiar with this syntax? See, now, again, I question you, and you're like, I don't know. All right. Yeah. This is fine. This is fine. This does reference with array syntax on this character string literal. Okay. Now I've put it in that local variable str. Does this code compile, basically, is the question I'm asking? No. No. That's a pointer again. In case you don't know this, if you basically look at a C array, it becomes a pointer. I find this incredibly frustrating. This is like this falls into the category of the one feature that I would want to remove from C++. Okay, why does this code compile? We've all done this. If you've programmed in C++, you have written code like this. Implicit conversion of a string, implicit conversion and string. But can you tell me specific? Does anyone want to go specific? I think I heard basically the words implicit constructor from a construct.
Temporary object creates bound to const reference, and this temporary object is using constructor from hairstyle.
Okay, temporary object bound to the const reference that was from the single parameter constructor for string that takes the const character pointer. But I passed it an array, right? Is that what we? Oh, well, sorry. Yeah, so I have this string literal thing that's going to decay to a pointer that's going to match the const character pointer constructor, and the implicit conversion is invoked. Just for the record, this isn't actually annoying yet. This is normal. And it calls, well, the constructor is, number 3. Oh, the destructor. Yes. Yeah, the destructor. Yeah, where is the destructor called? What the heck? Why not? Yeah, where?
It's called at the end of the expression.
And then, yes, so on line 7, that's, I believe, the expression you're referring to. Yeah, at the semicolon, basically, is where the destructor for that temporary string is called. That might come up again in a minute. We'll see. This is handy, right? We all use this, right? This is good. Good. We'll see. It's handy, right? All right, let's do a code review. One of your coworkers has just submitted this PR. Okay, yes, the people in my last time I gave this complained about a map of character, whatever. It's a map of character pointers to int, except that part, okay? I'm gonna wait. I got time. I don't know if you have time. Does this pass code review? No. Why not? And not because of the character pointer in the map. That's the part that I'm focusing on right now. What's the problem? Where's the problem? Two different types of pairs. Yes? Who said that? Okay. So I've got a pair. The map is a pair. Well, it's a map of character pointer to int, and I'm passing it to a function expecting a pair of string to int. This compiles without warning with any tools that exist today. All right. Yeah, that's the bug, that's the issue. That's the implicit conversion, extra string copies being hacked. Okay, I fixed the code. All right, it's now a map of string to int. Nope, why not? The key should be const. So does compile? Yeah, but what's happening? Also copying the string. Have you seen this issue? Okay. All right. Well, yeah, you're like, yes, I definitely have. Yeah. Okay. So why the actual value type of a map is a pair to const key type to the mapped type. So why do these two examples I just did compile? Because pair has this handy implicit conversion constructor for me. If you see it, it's templated on both first and second. So this means that a pair of anything is implicitly convertible to a pair of anythings that are convertible to the things. And also, as we discussed, basic string has this implicit conversion constructor. So as far as I can tell, the implicit conversions have, quote, always been there since the language was standardized. Member function templates were added relatively late in the language development, but before C++ 98 was finalized. And as far as I can tell, they've been there since forever with string. As soon as we had a string, this was a thing. Are these bad? Pair is bad. All right. You're going to agree that pair is bad. You agree that string is... I think string is bad. Very few people agree with me on that. Pair, okay. All right, so I've kind of mostly stuck with C++ 98. You've seen this issue? Do you see it? I'm going to wait for some head nods, at least. Yes. So what happened here? I was doing some refactoring. Where is my pointer? Where's my pointer? There it is. That was weird. I was doing some refactoring. This thing probably took a const character pointer at one time. I upgraded to, I don't know, C++ 98, and I made it a const string reference. And yeah, so I have the string being constructed on line 6, and then I'm getting a pointer to the string data, and then I am making a copy of that string. Let's go back to this example, which I hope you can see this time. I'm now using a C++ 11 ranged for loop. You see the problem? This const is missing again. So I'm doing a ranged for over pair of string to int. Okay. And that should be const string to int. Lifetime of get data is not an issue in this case. The transformation that the compiler does for us with a ranged for loop is going to do basically auto ref. It's going to do a forwarding reference, and lifetime extension rules will come into play. This is safe. The problem with lifetime in this kind of scenario is if I called like get data dot make something else, basically. And then the get data that owned the something else, now that's going to go away and the something else will be left behind. But that issue was fixed in C++ 23, like lifetime of a init and ranged for or something like that. And it's been implemented by 2 of the 3 compilers, I think now. I think that's correct. Okay, so why did I have these last 2 specific examples? There's a very specific reason why I started with the character pointer to string and the pair of map. Does anyone guess?
The map type is a pair when you get it out, is it not? When you're all iterating over it?
It is a pair type, yes. But I mean, like, I have very specific reasons for these 2 specific things. Have you ever gotten warnings from your tools on either of these things? Someone, you haven't? Oh, I need to teach you something here then. Both of these specific issues actually have tooling support for them. They are so common that GCC will generate a warning right here. I can click on it and even show you. Come on, do your job. All right, there we go. Warning. So this is modern GCC. Loop variable data of type blah, 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 binds to a temporary. Basically, I'm making it's telling me that I'm making an implicit copy of each loop element. GCC has this warning built in. The C string to C string to string has been in Clang Tidy's modernized checks for several years. You need to be using Clang Tidy's checks that'll catch those specifically if you still have any left in your code. They're so common that tools went out of their way to warn us on these things. All right. Don't know if I'm moving fast or slow because this is where we start to get bogged down in a minute here. Maybe they didn't know better in 1998. Maybe they did. Do you think they knew better when the standard library was designed? Yeah. Oh, I'm not going to repeat that for the camera. Okay. More effective C++ by Scott Myers, 1995. He's encouraging the use of this new explicit keyword that was added to the standard library to void implicit conversions with your types. How long ago was 1995? Yes, older than some of you in the room. I would say older than a fair number of you in the room. Some of us are older than 1995. The C++ Coding Standards book by Herb Sutter and Andrei Alexandrescu, neither of which are in the room to defend themselves here, says, avoid providing implicit conversions. Implicit conversions have 2 main problems. First, they can fire in the most unexpected places, and second, they don't always mesh well with the rest of the language. This is an example from that book. And it asks the question, what does display of 5 do? Go ahead, you can talk to each other. Try to figure it out. Wait, say that again?
Double is implicit conversion, while conversion version 2 unsigned in for widget constructor.
Yeah.
It requires user provided
Yeah.
version, so probably double wins.
Okay, all right.
Unless you're aware of any double promotion rules.
Okay, have you come to a consensus? Who says the double overload is going to be called? Who says the widget overload is going to be called? Okay, so this is from the book. Oops creates and displays a widget. So you're all right. Who said that? Except you're wrong. There's actually a bug in the book. This does in fact call the version that takes the double. The built-in conversion is preferred over the user-defined conversion. And just so you know, yes, if I change the function signature to take an integer, it still does the same thing. If I change display to if I pass a double explicitly, it still does the same thing. I can't make it do what I found the book says it does on any compiler that Compiler Explorer supports today, which is a lot of compilers. Have you scrolled through the list of compilers that Compiler Explorer supports? Are you familiar? Who is not familiar with Compiler Explorer? Are you afraid to raise your hands? One hand? Okay. 2 hands. It's also known as godbolt.org. Are you familiar with godbolt.org? That's okay. It's the same website, but yeah, Compiler Explorer has all of the compilers. Well, no, not all of them. All right. The core guidelines. Now, I want to be clear. I went all the way back to the very first commit that's publicly available for the core guidelines, which was on September 9th, 2015. And they say, by default, declare single argument constructors explicit. Do you agree with this? Who follows this as a standard? Do you have tooling that supports this? Yeah, CVP checks and whatever. I don't know. What tooling do you use?
We use CTAD and Sonar Cloud.
Clang Tidy and Sonar Cloud. Okay. And Clayzy. I haven't used Clayzy. So let's look at the library features that were out in C++ 11. We got function. Okay, go ahead and look at this code for a second. Well, someone's playing music real loud outside. This is going to compile with no warnings. Do you see it? Okay. So I'm creating a function object that returns a void and expects an int. What am I passing to it? A lambda that expects a float and returns a void. Do you want this code to compile? What we're going to, maybe. Okay, so I've gone ahead and I've explicitly created a standard function object on line 7 that creates my callback that expects a float, right? Now I'm passing it to the register callback function, and it's expecting a function that takes an int. Again, compiles with no warning. Do you appreciate what this code has done? Okay. So I've just gone ahead and made it slightly worse again. So I'm creating the function that takes a float, and I'm passing it to a function that expects an int, and I'm passing that to a function that expects a float. What's it doing?
Does it copy?
It is copying, yes-ish, kind of. There are copies happening, absolutely. There are copies happening. Go ahead, think about it for a second. I'll get a drink of water.
It's the original double.
It does what, sorry?
It truncates the original float.
It does. But like, how bad is it? Like, how bad could it be? It's just truncated my my float to an int and back, right? All right. I have to start extracting more interaction from you. Step 1, type erased function object, which is almost certainly going to fall into small function optimization. Are you familiar with small function objects? SFO, SSO, small object optimization. It's a bunch of different ways of saying the same kind of thing. So I'm probably not doing a heap allocation on line 12 because this is about as small as the function can get. This thing's going to become a function pointer. Almost certainly will be compiled as a function pointer, the lambda, being used to initialize that. Now I am passing that to a function expecting a function object that expects an int. So I am wrapping that function object inside of another function object. And I'm getting a heap allocation in the process. Because by definition, an object that has small object optimization cannot fit itself inside of itself, right? Pretty sure you can't. Almost positive. I haven't come up with a way. And then I am passing this to another function expecting that, so I'm wrapping that function again. If you were really, really smart, you might be able to write your own function implementation that peeks inside and says at runtime, wait a minute, do I already know this thing? And if I do, pull it back out. But that's not what's happening. Instead, when I call it at this point, I have function 3 calling function 2 calling function 1, which is calling the lambda. Good? It's not Lisp. Okay, let's talk about tuple. Tuple is implicitly convertible from a pair. So I've got back to my loop over the map things. Does it look good to you? Types match, right? Const string and int. It's still not a pair. Okay, so I am doing what? I'm doing copies. Implicit conversion. Implicitly, yes, okay. So it is also implicitly convertible from the set of convertible parameters. So on line 7, I have a function that I'm passing what to? An int. Passing an int to it. And what is it expecting? Tuple of float. That's what I wanted to do, right? Come on. All right, does this compile? I have a function expecting a tuple of a single element, which is a function that takes an int, and I'm passing it a function object that takes a float. Probably does compile. Yes, it does compile. Why wouldn't you want it to compile? Obviously, this is what you intended to do. Yeah, like, of course. I wanted to accidentally make a wrapped copy of my function object with no analysis possible. Yeah. Construction of the new tuple containing the function object, wrapping of the function object into another object.
Would doing in place on the object that you are copying from?
Doing in place on the object that I'm copying from, I know of, because there's no in place for function, and that's really where the really annoying problem happens.
Yeah, because that's the thing here. It's always copying and wrapping it up.
Yes.
It's not an implicit conversion. It's like if you're trying to do it into a float, you will get in place of that object the float value.
But it is happening because there is an implicit conversion constructor. And that's the part that I want to focus on here. Okay. Well, because there's two implicit conversion constructors, right? There's the one for tuple that's willing to implicitly take a single parameter when it's a parameter tuple of 1, and there's the one for function. So I know some of you are like, oh yeah, but the standard, the C++ standard will only let you do like one level deep of implicit conversions, which is like technically correct, but well, it gets worse. Okay, let's just make it worse. All right, I have unique pointer. Okay, I've got a unique pointer of int, and I'm passing it to a function that expects a const reference to a unique pointer of int. Now, yes, I will state, just for the record, don't do this. There's like virtually no meaningful way to pass a const reference to a unique pointer. There's nothing that you can do here. You can't take ownership or whatever. You should probably just spell that as int star, right? Just so you know. Okay, so what state is PTR in on line 12? It's fine. It's fine. I didn't touch it, right? I didn't make unique. This thing's still going to be good. Yeah, okay. All right. I just realized I should change the slides to make it more annoying. Now I am calling move, and I'm passing it to this function that expects a const reference to a unique pointer of int. That's what? Wait.
It's fine.
It's fine. You're saying it's fine. Okay, what is move? Cast to an R value reference. If any of you have been in my classes before, I hope that was at least some of you saying that. Okay, so no big deal. Cast to an R value reference, and fine. Then I just like decays to a const L value reference or whatever. That's fine. That's fine. Okay, that's fine. Okay, I just changed the signature of the function to expect a unique pointer to a const int. What's that?
Will this compile?
Absolutely. It will compile with no warnings, no diagnostic. There's no tool to tell you what's happening here.
Temporary object phrase is moving to temporary object.
Yes, I mean, you could just you could say that to almost every one of these and you would be correct now. It's like, yeah, it's the temporary object. But it's a spectacular, we have to think through this. I'm not giving you a hard time, just for the record. You have to think through this. So this is the compiler willing to materialize a new temporary object on the stack for me that is unique pointer to a const int. Now, this is a completely different type from the standpoint of the compiler than unique pointer to int. It just happens to have an implicit conversion constructor from an R value reference of the non-const version of itself. That's why it compiles. All right.
What is the legitimate use case for that constructor?
The legitimate use case for that constructor? I don't know.
Other than giving you a job, obviously. Is it a job program?
What's that? Painter, yes, but this is a special different overload, just for the record. The pointer from derived to pointer of base is its own separate implicit conversion that exists also. And we might argue that that one has a valid use case, but the one with the const one, I believe the actual argument is the smart pointers are supposed to model the semantics of regular built-in pointers, right? But in doing so, they confuse us and cost extra. We'll see what the next one looks like. I've changed this to a shared pointer of const int. Now, I'm not doing a move or anything on line 7. I'm not trying to confuse you. What is the type on line 6? Shared pointer to int. What's the type on line 3? Shared pointer to const int. How does this code compile? The implicit conversion from a pointer to a thing to a shared pointer of a const thing. Is this bad? There's a ref count increase, and that's what most people want to point out. And honestly, that's not the thing I like wandering around. I don't know if you've ever noticed that about how the talks I give. I just like walking around, and I have no idea if I'm not on camera at this point. Sorry, internet. I break the rules, and they invite me back, so it's okay. What was the comment? Ref count, yes, that's the part that concerns me. Yeah, so it's an atomic ref count, which is not free for sure. But the part that concerns me is the semicolon on line 7. Quite specifically. The semicolon on line 7 is where the ref count decrement happens. And now the decrement is a branch. Is ref count 0? Yes or no? If ref count is 0, then I need to destroy all the things involved in the machinery of the shared pointer. If it's not 0, then I continue on with my life. That's an extra branch, and it tends to be a fair bit of code inlined at that point as well, because it's a small templated function. Why don't we inline it, right? And if you're accidentally doing this all over the place, you can have code bloating issues. Kind of best case. Worst case, you're like jumping to cold sections of the binary or something to deal with the ref count going to possibly 0. I don't know. It's bah humbug. All right. Yeah, that's all of the steps that happened here. Okay. Now I have I'm registering the callbacks for my library. Let's pretend like I'm registering the callbacks for my library. So this is register functions, registering the functions. I expect a function object that wants a shared pointer of int, and I'm expecting a function object that wants a shared pointer of float. And I have 2 functions. One has a shared pointer to constant, and the other one is a shared pointer to const float. And I am, very helpfully, calling register functions with make pair of f1 and f2. Do you even want to think about what happens when I call get 0? That's the tuple element access. I'm accessing the 0th element, and like actually calling the function return from that. So copies, reference counts, decrements, and no implicit conversions of like floats or ints or anything right here. Okay. I can make it worse again, because this time I was trying to be helpful and I wanted to create the actual type that I wanted to pass. So it's a pair of what? On 19, pair, okay, we see that, that's a pair. What does the function expect? Tuple. And I'm like, well, I thought I was only allowed to do like 1 level of implicit conversion, but it kind of feels like I'm doing more than 1 level of implicit conversion here. I have to move faster, I think. All right. C++ 17. C++ 17 added lots of libraries. They very helpfully added file system directory entry to file system path via conversion operator, file system path to string via conversion operator. Oh, for those of you who are Windows developers, that one doesn't work. That's file system path to wstring, just for the record. That's implementation specified. But for everyone else, yes. String to string view via conversion operator, string to file system path via conversion constructor, a object of type T to an optional of view that is convertible from T via conversion constructor, an optional T to an optional of view if they're conversion constructible, T to variant of something containing a T via conversion constructor, and from anything to standard any via an implicit conversion constructor. And CTAD hides more of these things. What is CTAD? Class template argument deduction. Well, you'll see if you haven't seen this. This is a little example I put together. It doesn't fire, there's no warnings here. This code has, well, okay, first of all, there's a bug. Find the bug and why does it happen? And second of all, I want you to copy the implicit conversions. Go ahead. You can talk to each other. Why not? It's not like it's an exam day or something.
We can dereference the empty optional, right?
Dereference the empty optional. No, yeah, I'm testing it on line 17. 17 is not the bug. View on a temporary. You know what I think you might do? You've.
You return a string view on a
Yes, definitely, which is what you just said. Yes. Okay, so that's the bug. I'm returning a string view of a temporary on line 10. Now, of course, helpfully, I have a string that I'm returning on line 10. That is implicitly convertible to an optional of string view, just so you know. That's helpful, right? Come on. You're supposed to still be laughing at ourselves here. Okay, now how many implicit conversions do you count? A lot? Someone might end up coming up with like 12 or something, which isn't what I said, what I thought, but you know what? You might be right. I don't know. You got 4? 5, you think?
Yeah, because the optional is implicitly convertible.
Yeah. So that actually might make 6, depending on your argument here. Optional convertible to bool. So, yeah, I have like 4 plus 1, basically. There's like path to string. I exercised all the things, but then also the optional implicitly convertible to the bool. And then the plus 1 in my head was like, do I count string to optional of string view as 2 conversions or 1? I don't know. No, that's true. Optional is not implicitly convertible to bool. It is explicitly convertible to bool, which implicitly happens in an if statement.
That's okay. That's where it's supposed to happen. That's why it was invented, to be placed here, so don't mock on this particular conversion.
Okay. So the comment was, this is the entire reason that explicit conversion constructors were invented so that we could safely use them here. Explicit conversion to bool. But yeah, like the explicit keyword for conversion operators was added to the language basically for this exact case. Yes, because we don't want things implicitly converting to bools all over the place because it goes really wrong in that play. I have examples of that too. All right, let's keep going. All right, variant. Does this compile? I have a variant of int and a double, and I'm assigning it a float. Yeah, it compiles. Yay. Okay. But at least this doesn't work. A variant of optional, like 2 different choices here, that's not going to work. Well, I can't find which one I mean. But this does work. A variant of a single optional to a double, of course, can be initialized with a float. All right. Did anyone see my stronger types, better C++ talk I gave at C++ under the C? It's a fun talk. That one was good. Yeah. Well, anyhow, I'll let you mull over that. Take a picture if you want to real quick. Otherwise, I'm moving on. We need to get to worse things. All right. So let's talk about CTAD's influence. What is the value of p dot first? P1 dot first, that is to say. I didn't mean type. What's the value? 3. Right, so reading this code, there's no way for, unless I like literally read every type, I don't know that that's actually a pair of int versus a pair of doubles. Okay, so what is the value of p1 dot second in this case? Note the carefully placed braces. I'll give you a hint there. Yeah, it's undefined-ish behavior. I did do that, in fact. Yes, after I left the block, where the comment is, right? So if you don't see it, I have a pair of string views on line 7, and I have a pair of strings on line 10. I'm assigning the string to a string view. The strings are destroyed on line 12. Line 14, I have string views that point to memory that's been freed. Not necessarily been reclaimed, but if I try to do anything with those values, I absolutely have undefined behavior in this program. Okay, what is printed? I've got these 2 pairs of function objects. Function is so helpful for these slides. Oh my goodness, I had so much fun with it. It's fun. I'll let you look at it for like a minute and then I'm going to move on. Just for the record, I ran the code to figure out what was printed. I didn't try to trace through it. You have to ask yourself, what is the type of P1 versus what is the type of P2 versus what do these functions do? Yeah, everything does eventually get truncated. It is 3 and 4, so it's 3i 4. No, 3f 4i. Darn it! All right. C++ 20 probably helped the situation, right? We got implicit conversions from array to span and range to span. Are these generally harmful? Probably not. No accidental conversions, no accidental copies. Yes, accidental lifetime issues, just like string view, are possible. C++ 23, we got conversion from u to expected of t, if it has an implicit conversion if it has a conversion available. We got pair-like thing to pair and tuple-like thing to tuple. Now, this is kind of nebulous wording in the standard for pair-like thing. This does not mean that it necessarily has to just implement that like tuple protocol, in quotes, whatever it is, just like get 0, get 1, right? It's more like, well, it's well-defined in the standard. Sorry, I'll get to that slide in a second. It's well-defined in the standard. I have an example of it. There's like 6 things that are interconvertible with each other that all match the pair-like thing description in the standard. Okay. So this helpfully compiles. Like, wait, what is it even doing? I was just looking at these slides during the last talk, trying to remind myself of what is it actually doing here. I don't even. So I have a tuple of a string and a double, and that is implicitly convertible to a pair of expected, of optional, of string, where the int, that int there, in case that's not clear, the int is the error value from the expected, so that's not really actually coming into play here. It's just there to confuse you. And then the float is the second member of the pair, which is implicitly converting from the tuple that has a double in it. All right, so like, how bad is this? Oh yeah, I'm gonna run over. I'm not gonna run over. Okay, so these two things, where I got the types right versus where I got the types wrong, basically, it's like double the 2.5 times more code generated. Well, and then I've got this tuple-like thing and pair-like thing. So with the help of the standard as of C++ 26, a complex of double, so that's like the imaginary and, wait, what are the two parts? Real and imaginary, thank you. The real and imaginary parts, which are both doubles, are of course implicitly convertible to a tuple of floats. And then if I help it out a little bit, I can convert those things to an array. Now I'm cheating here on array. I just wanted to create an array so I could do the next two parts, where this array of long doubles is implicitly convertible to a pair of ints, and the pair of ints is implicitly convertible to a pair of cars, of course. So all of these things are explicitly allowed in the standard. Is there any line of this code that you can get a warning from? Depends on your compiler, first of all. Truncation from int to float on which line? Oh, int to char? No, that's not going to give you a warning, probably. Yeah, but I need a line number. Nope. Okay, so first of all, do me a favor. Who uses Visual Studio in this room? And I don't mean Visual Studio Code. I mean Microsoft's compiler, cl.exe. Okay. So you all could get warnings from this. Who never uses Visual Studio's compiler? All right, the rest of you, you're out of luck. Sorry. Line 9 is where you might get a warning if you don't use Visual Studio. So this manual array to array thing, because array doesn't have a constructor, rest will not warn on why. Why will they not warn on GCC and Clang? Does anyone know? Someone knows. Someone who's in my class knows. Not with GCC or Clang, no.
Maybe because these template constructors that accept everything.
Yeah, but it's more specific than that. The reason I can't get a warning with GCC or Clang is this handy little thing called -I system. All of my standard library headers are included with system includes. By default, system includes suppress all warnings that originate inside of those files. That's helpful. Visual Studio does not exempt its own standard library from warnings. That is why you can get warnings with Visual Studio. All right, let's talk about these things. Okay, so I have two different versions here. I have this not smart. This is the thing where I'm creating like a pair of functions on line 21, and then I'm like passing that to a function that expects a tuple of functions. Okay, this is the not smart version, and this is the smart version. So the types all match here with the smart version. The types do not match with the not smart. Does anyone want to take some guesses? First of all, can I get warnings with this stuff? There's actually, I didn't give you enough time. There's one line of code in here I can get a warning. What performance difference do I see? Do you want to take a guess as to what this performance differences are with like copying and wrapping of function objects and that kind of thing? Orders of magnitude. Give me like 10 times, 100 times, 1,000 times. Who says 10 times slower? Who says 100 times slower? Who says 1,000 times slower? Who says 10 million times slower? 1 billion. Okay. It's about 10 times slower in the test that I ran. Interestingly, it didn't actually depend on optimization level a whole lot. Like 01, 02, 03, like the times decreased, but the relative 10 times stayed the same. Here is the quick bench. If you want to look it up yourself, go ahead and grab the QR code. So you can play with this and see whether or not I'm making stuff up. All right, so how do you find the cost of these implicit conversions in your project? Counting the cost. W conversion can find the float to int conversions, but only if explicitly enabled. What about these implicit conversions between pair, tuple, function types, etc.? Bless you. So I ran this thing with prof, and I want to point out, so I learned something in a talk yesterday afternoon, so there's an update slide coming in a minute. But with my naive execution of prof, I see no constructors being called, because helpfully the compiler optimized them all away for me. So then I ran, which one is this? This isn't prof, perf, prof, whatever. Oh, shoot. Does anyone know what output this is? Yeah, all right. So if I look at this, I might see, like I ran my test for like 100 million executions, and if I'm counting the calls, then I might see suspiciously high numbers of like, why do I have 400 million function calls? I thought I should have 200 million kinds of things. So a suspiciously high number of malloc and free, a suspiciously high number of standard function invocations, suspiciously few constructor calls. But I'm cheating because I already knew what the problem was. This, for me, sums up most of the real-world problems I've dealt with for optimization, performance, hidden conversions, accidental copies, things that are very hard to track down. I did make the issue more visible for myself here. And this is using K-cache-grind. And I did a search for things that look like templated conversion constructors for function. And I did a debug build so that they actually showed up in my run. This was a very expensive run. If you notice, I didn't run it for 100 million times because I got bored. I ran it for 17 million times. All right. This is one that my friend Ben Dean gave me. Oh, you look at that. What does this program do? Print success. Why? lambda conversion to function pointer, and implicit conversion from function pointer to bool in the F. I don't want the implicit conversion to bool. All right? All right? You don't have to have it. No. You don't have to have it. I could have put equals null pointer in there, right? It doesn't have to be in the language. Implicit conversion from pointer to bool does not have to exist. All right. Just so, because who's using AI tools at work right now? Yeah, okay. It's virtually 100. Oh, who's using them at home if you're not using them for work? Who is told not to use them but is using them anyhow? All right. So neither Claude nor GPT saw the wrapping of a function as being a potential problem. GPT sees the function-to-function conversion and says that's not going to compile. It's wrong. Claude and GPT both think that the get could be my performance bottleneck. Just so you know, it's not. It's not going to be over O0. It's not going to be my performance bottleneck. Neither see the implicit conversion from pair to tuple that causes the copy. They're okay with that. Both see the int to float conversion, and they're like, that's where your performance bottleneck is. Like, that's bad. The code is incorrect, right? Is it my performance bottleneck? Highly improbable. I mean, we already know that it's not for this code. All right, so our best practices takeaway, and we got just enough time to wrap up here. Your code is broken. Performance measuring tools don't help. AI doesn't help. Warnings don't help. Human eyeballs don't help. You're just bleeding tons of performance and you have no hope. You just have to remove all, I'm sorry. Yes, okay, so Rust is more strongly typed. Although I just learned in the opening keynote that I'm allowed to add implicit conversions to Rust too. But this is in the standard library. They're not there. I mean, there's the built-in ones that we inherited from C. Is Robert here? He's not. Anyhow, so I had to meme it. I want you to stay awake tonight. Actual takeaways. Please, please, please don't make this worse. Strongly avoid adding implicit conversions to your code. I know that they're handy. You're like, but it makes my calling code cleaner. No, you have the wrong types. You got to just make your type stronger, please. Never, ever have templated implicit conversions. Oh my goodness. If you're going to have implicit conversions, please don't make them templated. That's where all these problems come from. It's templated implicit conversion constructors and all these built-in library types. Sometimes run performance analysis on debug builds. That might help expose some of these issues. And this is what I learned. Million Wolf, I don't know if I'm pronouncing his name correctly, in his talk yesterday. You can run perf with call graph tracing, and then it will actually expose a lot of these things for you. And search for things that happen to look like copy constructors in your performance reports. And then consider this. Consider that it's possible to do -w system headers, if you're not on Windows, to expose the warnings that are generated from inside of your standard library. You're gonna have to disable a lot of warnings because libc++ and libstd++ do not try very hard to be clean of warnings. Yes?
It's something about the standard library because all the third parties that you use, all their headers usually go to iSystem, and there's
Yes.
they drive in less.
Yes. So the comment was it's not just the standard library, it's every other library you use as well. You can, just try it and report back to me. Are concepts helping any of those templated conversions? And most of the...
Library implement concepts to help alleviate some problems.
Could the standard library implement concepts to alleviate some of the problems? And probably not now, because it's too late to go back on it. All right. So no one exactly surprised me, but both of you two were very interactive and giving good answers, like 2 rows back here and you in the front row. So you two come up here and we'll talk about the book. What's that? Okay. But I have stickers also up here as well. This is my attempt at this. This is my attempt to make Clang tidy so you can get an alert on implicit conversions, like basically user-provided implicit conversions that you're accidentally using. Now, I know at least a couple of people are starting to look at this. I hope they're starting to. I got some good feedback at CBPCon, which was not a recorded talk, just for the record. That maybe this will, hopefully with someone else's work, this can get formalized and rolled into Clang Tidy, and we can start to track these things down, which would make our code safer, more correct, and more better performance when we are exposed to these things. So yeah, implicit conversions considered harmful, and I'm out of time, but thanks for coming to my talk.